Hello, Algebra 2 class. Mr. Thomas back again. We have another video, another instructional video that is. Today, we're going to cover two lessons, 3.3 and 3.4. The first one, systems of inequalities. All right, our goal for today is to solve a system of linear inequalities. So let's get started. This is a fun one to handle. Notice we have our little curly brackets to let us know it's a system, and there's going to be a solution. However, yesterday you learned about systems of equations with equal sign. Today we're dealing with inequalities, so we're dealing with less than, greater than, or greater than or equal to, or less than or equal to. So let's talk about what will look different with these. The first thing I want you to be aware of is that when we go to graph these, we're going to graph these inequalities, we have to get them in basically slope-intercept form. It's not going to look exactly like slope-intercept form because it's an inequality. But if you remember, slope-intercept form is y equals mx plus b. So we want it to look like that, and notice the second one is good. First one, we're going to have to move some stuff around. So let's look at what they did. In order to get this first equation into slope-intercept form, they made it blue. Then we're going to add, actually subtract 2x from each side. That cancels there. This becomes negative y greater than or equal to negative 2x minus 3. Then, to get that y by itself, they had to divide by negative 1. Remember, there's a little negative 1 there. And if you remember from inequalities, when you divide or multiply by a negative number across the symbol switches. So this is going to end up being y equals less than or equal to 2x plus 3. Then as far as graphing, it's graphed like slope-intercept form. The 3 is sort of our y-intercept. So we go up here to 3, and then we go to our slope, up to over 1. Now you'll notice a couple of things. Number one, you'll notice that this area is shaded, and you're like, well, how do I know which area to shade? The less than, just remember that less than is fewer or lower, and so try to picture the slant of this line, and if it's less than or equal to, you're just going to shade everything below the line. If it's greater than or equal to, like our next example, it's everything above. Another thing that you will notice is that our line is solid. Now, if this were just simply less than, our line would be dotted. But since it's less than or equal to, it's solid. Keep that in mind as you graph. Then our second equation, they find the y-intercept at 1. Then the slope is down 1 over 2. Right there. You shade everything above. And so then our solution would be where they overlap. So where this part is less than, and where this part is greater than, and so it's going to end up looking something like this. Here's another example. So we have two equations, except this time we have an absolute value bracket. So first I'm going to find y is less than or equal to 3. I find 3 on the y-axis, and I draw a solid line because this is less than or equal to a solid line, and since it's less than, I shade everything below it. Then, for absolute values, the shortcut is this. You're going to have a vertex, and the vertex is based on, the x value is based on what's inside that absolute value bracket, and the y value for the vertex is anything after it. So there's nothing on the y So that's a 0. Inside the absolute value bracket, I have a -1. If you see an X, a symbol, and a number inside a parentheses or bracket or square root box and it's telling you to solve or graph, you can just drop the number, switch the sign. So my vertex is going to be at 1, 0. Then for my slope, or I call it kind of slope because it's not really slope, we look at this number right here. And for absolute values, because when we solve this out, we would make two equations. The shortcut is just to know that it's going to be a V shape. So I go up 1 over 1, and then up 1 over 1 the other direction, and I get my V. The reason why it's pointed up is because that's positive. So then to solve this system, I just show where they overlap. So the overlapping area would be this little section right here. That is solving systems of inequalities. We're going to look at one more complex thing. We're not going to see a whole lot of this, but I wanted you to be aware of it. It's called linear programming. You're going to do all the same things that you just did, except we're looking to find what's called the feasible region. So that's where everything overlaps. And then we're finding the maximum P for the objective function P equals 2x plus y. Now you're like, hold on, what did you just say? It's okay. I'm going to step into this. We're going to have one question like this on the homework. You'll be fine. The first thing you're going to do, you're going to graph all the equations. So you would move all of these into slope-intercept form. Now they don't do that for you, but you could do that. Now it doesn't show, but the x being at 0, that is this line. I'll draw this one red. The y at 0, looks like my pen is off. It's right there, so you can kind of see where these lines mark, and it shows you the feasible region. So all the areas where there could be a possible solution are this shaded area. And it's just like we did those last examples, except now they've added more inequalities. So once we have the feasible region, you'll notice we have vertices right there, here, and here. So we have a vertice of this shape at 0, 0, at 0, 2, at 2, 0, and then this one is at 3, 1. We're going to use those to find our maximum. So let's look at what that looks like. So these are all the vertices I just showed you guys. So P has a maximum value of 7. Oh, that's the answer. Let me get to it. All right, so we're going to use that equation that we just saw right here. P equals 2x plus y. They're going to bring that equation over here. P equals 2x plus y. And basically what's going to happen is we're going to plug our vertices into this. So P equals 2 times 0 plus 0. That value is 0. Then I plug in my other vertice. 2 times 0 plus 2.5. That gives me a 2.5. That's higher. And the maximum is going to be the highest number that we see in this. So then, let's try the vertice of 3, 1. 2 times 3 plus 1 equals 7. Right? It already tells us that's the maximum. But we have 7. And then, let's try this other one. 2 times 2 plus 0 equals 4. So our maximum value is 7, and that is at the vertice 3, 1. And so that would be our answer. Now, I think there's only one question on the homework for that, so you'll be fine. The biggest thing from this lesson is understanding the inequalities, making sure you do a dashed line if it's less than or just greater than, and doing a solid line if it is less than or equal to, right? So that's a solid line, and if it's just less than, it's a dotted line. Keep those things in mind. If you need help, do not hesitate to message myself or Miss Colette. Good luck and have fun with this. I'm going to go ahead and take the elevator on down.